So I repeat it once. See, this is called as ellipsis. This was there in C++, C++ also. This was more powerful there, but Java has introduced in version 1.5. See, initially when Java came, Java tried to remove all the complex things from C++ and make it more simple. People started adopting it. But later when the programmers, professional programmers were trying to do flexible things or some advanced features, they were not there in Java. So slowly they introduced that in later features, later versions. So one of this feature is this one. But here in Java, it is limited that once you set integer, then all should be integer only. This is all same data type. There's a limitation. And automatically that will convert into array. Now here, if you see, we are not sending an array, but we are sending 3 parameters. That will convert into array like this. 6 parameters convert into array. 1 that will also convert into array. So whatever the number of parameters you want, you can pass as many parameters as you want. So it is just like a overloaded method. This one method acting as many different methods, one function acting as many different functions. So it is just like that. And even if you want, you can pass an array also. It will take that as an array. Alright, but as it is taking all integers, so you cannot pass floats. So take this one quickly. Void fun float a, then float x means what? When you call this fun method, you must pass one float 3.5f, then rest it's optional. You can pass one float 3.5f and 6.2f, 3.4f. So these two will be taken in this array and this is taken in A. Fun 6.2f 493. This will be taken in this A and these will be converted into float type and they are taken in this array A. Right? So can I call like this? Nothing? No. One parameter is mandatory. Then remaining as many as you want you can pass and all of them must be float. Void fun1 integer x float y. First parameter must be integer. Then after that, as many parameters as you want you can send, 0 or more, but all of them must be float only. That is the meaning. Right? Void fun2 integer a comma float b comma int c. One integer, one float mandatory. Then after that, as many integers as you want you can pass. That is the meaning. So take these some examples. Already for this one I have shown you what are the valid calls or not, and these are some other examples I have given. So this was variable arguments, variant arguments or variable arguments. Now, next, what are the ways how you can call a method of a class? Let us look at this. See, I have a method static void display. Same first method I am writing. System.out.println, it will say hello. Now from here, I will call method display. This we have already seen it. This is the method. Now this is a static. This is static. A static method, that is main, can call only static method. That is the reason we were declaring it as static. If I don't make it as a static, right, it is non-static. It is non-static. Now this method is non-static. Okay. How you can call non-static methods from static method? This is a main method. So I cannot call that one directly. Then how I can call it? So for calling a non-static method inside a class, inside a main method, first of all create an object of a type class, method test, t assign new method test, and then t dot display. You have to create an object of a class, then call the method. Directly you cannot call this one now because it is not static, non-static method. Void display. So now you have to take calling non-static method. So the topic is calling non-static method. So if a non-static method is there in a class, then main can call that method only by creating an object. After creating an object, it can call that method upon an object. So take this one. Method overloading. Let us see what is this. Class overload test. Now inside this class, I will write one method for finding maximum of two integers. Already we have done this one. I am writing it again. Return x greater than y, then return x, otherwise y. That's it. Now this is public static void main method, and this main method, I guess I will not have enough space there, so I'll write on main method here. Okay, I'm writing main method here, public static void main method. Then I will create the object of this overload test class, T assign new overload test. Okay, there is no space, it looks like a space, so test. Now system.out.println t dot, it's a non-static method, I wrote a non-static method, right? So ct dot max 12 comma 6. Yes, I can call that method. Till here we know. Already I have written this method, so already I have used, but now I made it as non-static. If you want, you can make it static also. This overloading is not related to static, non-static. You can make static also, independent of that. But I am using non-static, so created an object and call. Now what I have to show you, watch it. T dot max 2.5f comma 3.7f. Can I call this? I am sending float values, but I don't have a method for float values. I have only a method for integer. So I get a error here, right? Identifier undefined or identifier not found. What is that identifier? Method name max is not found. It's not there. So method doesn't belong to a class, right? So method not found. Then for float also, I should write separate method. For float, I should write one more method, right? So for float, I will write one more method. What should be the name of a method? I want to give maximum only. So it is finding maximum, so I want to give maximum only. Then it should take parameters float x, float y. Now the question is, can you have two methods with the same name? In C language, they were not allowed. But in Java, is it allowed? In C++, they were allowed. So is it allowed in Java? Yes, more than one methods can have same name. If Java says, no, you cannot have same name, then what the name I should give now? Max int, I will change the name, max float. Shall I give the name like this? Or max I for int and max f for float. Shall I give this typical names like this? No, thanks to Java, they allow us to have multiple methods with same name. But there should be some difference. What should be the difference? The arguments must be different. Yes, they are different. Float and int. That is int and this is float. Yes. So you can have more than one methods with the same name but different argument list, and such methods are called as not the same method. They are called as overloaded method. So that's it. This is method overloading. This method overloading. Let me finish, then I'll give you the definitions and everything. So here also I will write return same logic, integer x. See, I am using x and y only. So same logic is there. So overloaded methods. Writing two or more methods with the same name but different parameter list. Okay. Now, I have one more requirement. I want to say max 6, 12, 9. How? I am giving 3 arguments. There is only 2 argument method available. How you can send 3 arguments? No, I want to write a method for 3 argument also. So write it. Int max integer x, integer y, integer z. I will write the logic. But before that, are you writing the same method? See, max, yes. Int, all are int. It's the same method. No. 2 arguments, 3 arguments. Okay, number of arguments are different. What was the difference here? Data type of arguments was different. What is the difference here? Number of arguments are different. So yes, if the number of arguments are different, then also 2 methods are different. So let me write down the complete logic here. Return x greater than y as well as x greater than z. If x is greater than y and it is greater than z, then return x. Otherwise, check if y is greater than z. If so, return y, else return z. That's it. Just one single line I have written. Finding maximum of 3 integers. So that's all. These are overloaded methods. These are overloaded methods. See, what is method overloading? Just a definition I will give you, then I have to explain more about this one. Just a definition and you can copy this one. Writing 2 or more methods with the same name but different argument list. Listen carefully. Writing 2 or more methods with same name with different argument list is called as method overloading. But the argument must be different. How the argument list can be different? Either by its data type or the number of arguments. So I repeat once again the complete thing. Writing 2 or more arguments with the same, writing 2 or more methods with the same name but different argument list. Argument list is said to be different if the data type of the arguments are different or the number of arguments are different. So either data type or second thing is number of arguments. Right? Any of these 2 differences must be there. Then if these are different, then the methods are said to be different. So, and that is called as method overloading. So take this one. So I am calling all these. So it's a complete program. I have written a complete program. So this is a part of a class and continuation is on this side. Okay, because I started from here. So there was no space, I wrote it here. So this is the continuation of this one. Now, few more points on this one. See, name is max. Name is max. This max can find maximum of 2 integers, but this max can find maximum of 3 integers. Name is same, name of a method is same, but the behavior is different. Result is different depending on how many parameters you are passing. If you pass these 2 parameters, this method will be called. If you pass these parameters, then this method will be called. Depending on the number of parameters, the method call is different and the working is different. So there's a slight change in the logic, yes, so the working is different, right? So having two or more methods with same name, but their logics are different, then it is overloading, but also it is called as polymorphism in object-oriented terminology, right? In object orientation, it is called as polymorphism. Okay, polymorphism means many forms, many forms. So what are the forms? Max is having here three forms. You pass integers, that max will work, and this will work. So imagine that this is single method max. Actually, it is a single name only. Name is one only. No? We have written three, but imagine there is only one max. But it is acting for two integers also, floats also, and three integers also. So for all three, it is working, but working little differently depending on the data type, depending on the number of arguments. So here we are achieving polymorphism. Now here which method should be called? The first one. Here second method should be called. Here third. So who will decide which method should be called? Compiler will check this one, and compiler see that okay, here I should call this method, so it will link this one or associate this call with this method and associate this call with this method. So this type of linking will be done by compiler only, so we call it as compile time polymorphism. Okay, again this compile time polymorphism doesn't suit in Java, just we say polymorphism. This was there in C++. Alright, so compile time polymorphism. So in C++ we have compile time polymorphism, runtime polymorphism. So but in Java we have polymorphism through method overloading. That's all. Whether it's compile time or runtime, we don't talk about that one. We don't bother about that. Anyway, this is compile time in Java. It is sure that it is compile time, but we don't say it. That's it. So this is polymorphism. Polymorphism means one name or one word, different forms. For example, there is a person who know dance, that is Kuchipudi dance, Bharatnatyam dance, right, or disco dance. So these people knows different dance. Now if I say dance, Kuchipudi dance, Bharatnatyam dance, the method what I am saying dance is same. I don't have to say please dance in this so and so style. I don't have to elaborate. Just I have to say just start dancing, dance. So that person will dance in his style. This person will dance in his style. So to whom I am calling, it depends on that. So let us say like this parameter is like music. I started a music. So if I started a Western music, right, drums and this instrument, so then this disco person means this a breakdance person or whatever it is, he will start dancing. Alright. If I use some other instruments, then this person. So depending on the parameter, this is called. You pass this, he is dancing. You pass this, he is dancing. But all are dance only. All are dance only. Alright. So this is different, same word but different form. So that's how it is polymorphism. Alright. So this is a compile time polymorphism. So take this one, through method overloading we achieve polymorphism, and depending on the arguments the corresponding method will be called. All methods are having same name. Which method should be called is decided at compile time only, so it is called as compile time polymorphism. Again I repeat, method overloading is used for achieving polymorphism. One name, different methods are there. Depending on the arguments, the corresponding method is called. Second point. Third point, which method should be called is decided at compile time by the compiler, so it is called as compile time polymorphism. That's it. Now let us continue. I'll write down what is valid, what is invalid, what is allowed or not allowed, which is overloaded or not overloaded. Let us look at some syntaxes. I will write one method fun, which is taking just one integer a and returning an integer. Now one method fun, which is taking two integers, integer a and integer b, and returning an integer. Are they overloaded or not? This is the base one. Let us take the first one. Okay. Second one, is it overloaded or not? As per this one. As per this. Okay. This is the first method I wrote. This is overloaded according to this. Yes, it's taking two integers. Now, integer fun, float a, int b. Is it overloaded or not? Yes, overloaded. Now, integer fun, int a, float b. Check this. These two. Are they overloaded or not? First float, then int, first int, then float. One is int, one is float. It will not sum up and see that one int, one float must be there. No, order is also important. First value is a float, second value is integer. First value is integer, second value is float. Yes, this is also overloaded. This is overloaded. This is valid. Next, fun, integer a, float. Check with this one. Is it overloaded or not? So now all these are overloaded, and this one among till here they are all overloaded. Now this one among that, is it valid or invalid? Check it. Fun, int, return type is int, return type is float. So they are different. No, they are not different. A return type is not considered in overloading. So these are not overloaded. Wrong. A return type is not checked. Everything is same, name is same, parameter list is same, parameter is only one and that too integer type, everything is same. This is not overloaded. This is having ambiguity with this method. This is not allowed. This is not allowed. Alright. So return type is not considered. The order of parameter is different. Okay, they are different, no problem. But if the return type is different, they are not different method. So compiler says that redefinition of a method. Again, you are defining a same method. You are redefining a method. Or method fun is already defined. Why you are defining again? So a return type is not considered in overloading. This is important. Okay. Then fun int dot a int. Now this is not allowed. Leave it. Don't count it in the list. Now what about all this? See, this is matching with this one argument. This is matching with this one also, two arguments. This is not matching with these because they are having float. So this is not allowed again. When you write this, those are not allowed. Or if you write this, then this is not allowed. So they are same only. So this is acting as, if I give numbers now, this is first one and second one and third one, fourth one, and this one is having a problem with first one, right? It is not matching because of the first one, and this is not matching because of the first one and second one, not matching with first one and second one. So this acts as one argument also, this acts as two arguments also. Writing this method along with these method will be invalid. Separately you write on, in another program you write, but in the same class you are writing this method also and this method also, not allowed. Okay, so you have to take 2 points. Okay, you take just this point. I will show you once more this one. So the point is that return type is not considered in overloading, right? So it will ignore return type. Just check name and the parameters. Take that point. This will not be overloaded if you write integer a and fun with integer a and integer b and fun with int dot a. This is having a conflict with both of these. Take it quickly. So method overloading we have finished, and method overloading is used for achieving polymorphism. So that's all about methods in Java. So we have seen various type of methods in, or what all about method is there, we have discussed about that one in Java. Now let us start object-oriented programming. Let us start with object-oriented programming. See, till now we were learning about the basics of Java programming. So basics, what are the data types, what are the expression, conditional statements, loops, all these things, and till methods we have finished, arrays and loops and methods we have finished, right? Now, this is one of the important part, or that is, you can say, now from here the actual Java starts, I should say. So this is the important feature of Java, that it is object oriented, right? And object orientation is like a philosophy. It's a philosophy. It's having some principles, and those principles are based on some philosophy. So here syntax is not much important. Philosophy is important. Syntax you will learn. I will show you everything about the syntax. That is a different thing. But just learning syntax will not help you unless you start thinking in that way. You should be a philosopher of object orientation. So if you think in that way, then you can do programming better, and you can easily grasp a lot of things. A lot of things you can grasp easily, right? So with minimum efforts you can grasp the things. And sometimes if I say that this feature is there in Java, so you can figure out, okay, it may be like this. So this is important, very important. The philosophical thinking is very important. So that will take some time. So slowly you can learn that one. So try to focus on that philosophy. Focus on the philosophy. And my approach of teaching the rest of the topics from now onwards will be based on the philosophy only, right? So that is for thoughts, based on the thoughts. What are thoughts? Idea. Idea gives what? A design. So yes, it is more related to designing. The more better you design the things, then more better you can utilize object orientation, and more better you can understand Java. So Java is adopting a very good design or very best design in object-oriented programming, right? So once you get its flavor, once you get its idea, once you can get hold of it, then entire Java programming becomes easy for you. Whatever there in Java, advanced Java part, anything becomes easy for you once you get a hold of that philosophy. So my approach will be to feed you about that philosophy more and more so that you can start thinking in Java. See, you can think in terms of Java only. Speak in Java, I should say. You can think in Java and you can speak in Java. Yes, really it is possible. Really it is possible. Just knowing the syntax is different. It's like a labor work. This is right, this is allowed, this is not allowed, that is allowed. Okay, that is a simple thing. It's a syntax. Allowed or not allowed are the simple technical part. That's a technical part. Now somebody know what is right or wrong. This is allowed, this is not allowed. He will do it. But what you should do actually, that is based on the philosophy. Okay. Construct a wall. A laborer will construct a wall just putting bricks and mortar. He will construct a wall. But what for that wall is constructed? It is a house constructed, or a shop is being constructed, or a temple is being constructed. Don't know. He is just constructing a wall. So knowing these micro details, you will know how to write the code. But to work at higher level, you should have object-oriented philosophy. And one more thing I'll tell you, there are some subjects related to software engineering, that is object-oriented analysis and design, OOSD, right? Some subjects are there. Software engineering subject is there. Software project management subjects are there. So you study these things also. Mostly these are not technical subjects. So in interviews and all, sometimes they ask from here also. In interviews they ask from these topics also. But other exams, they won't ask from these subjects. But these subjects plays a key role in improving your thoughts to make better design. Okay. Now let us start. OOPS, object-oriented programming. That is principles of object-oriented programming will write. Object-oriented programming, OOPS, it's just a phrase or just a word to just S is added there. It has no meaning. If you really say there should be meaning, some people say it is a system. Commonly people say it's a system, or it can be style, or it can be a strategy, S for strategy, right? Just to make it as a word, just OOPS is added, OOPS, S. So S is added to that word. Actually, it's object-oriented programming. Now, principles of OOPS. What are the principles of OOPS? First one is abstraction. Abstraction. Second one is encapsulation. And encapsulation gives what? Data hiding or data hiding. Third one is inheritance. Then fourth one is polymorphism. So first, on this 4 topics, we will have philosophical discussion. Okay? Philosophical discussion, so you get the complete grip on object orientation so that the rest of the topics are easy for me to discuss. Otherwise, discussing rest of the topics, a lot of things have to be explained. But if you have that idea what I am giving you, you must listen from here. Okay, one important thing. You must not skip anything from here. You must listen everything carefully, right? Until I am covering object orientation. So it may take few sessions, but don't miss anything from here. Don't skip forward anything. So if you are familiar with, if you are following my track, how I am explaining you object orientation, then rest of the topics are just very easy for you and you can remember always, right? So if you just do little bit work on it, you can remember all the topics always. That I guarantee you. If you work and understand all these topics thoroughly, if you follow me perfectly. Alright, so I can give you the sense, I can make you understand Java so that you can talk in Java or you can think in Java. Let us start. What these are? So at once we will not study everything. So first of all, abstraction. So principles of object-oriented programming says that we should achieve abstraction. First of all, what is abstraction? Let us see. str dot to upper case. Do you remember this? Do you remember this? A string Ravi is converted to uppercase and we get a new string. Do you know how it is converting into uppercase? How it is converting? New string, what you get, see right now str is pointing on this object Ravi, and new object Ravi will be created, R-A-V-I, all capitals, and this will be pointing on this one, it is not pointing there. New object is created. Do you know how this is converting into uppercase? Don't know how it is working. Okay, you know that there are ASCII codes and capital letter ASCII codes are from some 65 to something, and if any lower case is there, then it is changed. Okay, little bit of logic you may be knowing. Okay, good. You know some logic. Like this, in string class, there are all the methods. Do you know the logic of all the methods? Don't know. Actually, just leave string class. This is a very common thing. Now I will bring one more class from Java, built-in class of Java. Then I will show you the methods. Okay, this method will do this, this method. Can you tell the logic behind every method? No. Then that's it. That's it. So we are focusing on using of these methods, not knowing their internal details. So that's what abstraction is. See, we learn that whenever you create an object, object is created in heap and this is pointing on this one. We learn this. And if the same literal is used, then two references will point on the same literal. We learn this. If without knowing also, can we use it? Yes, we can use it. So using the things without knowing internal details is nothing but abstraction. So in object orientation, we want to achieve abstraction. From whom? Right? Abstraction, that is hiding the details. From whom? Listen. Listen. We have a, so I am giving you more in depth, right? This is just more discussion, theoretical discussion mostly. So getting the idea of that one is more important, right? So there is no much syntax now, right? Little bit of syntax. Then after that, I'll show you everything about the syntax. That's technical. Now follow this. There is a software project. Okay, there is a software project. This is a project. Okay, let us represent this box, represent a project. How many programmers will develop it? Can just one programmer develop this project? No. If it is a big project, one programmer cannot develop it. It's a very small project, one programmer can finish it. But if it is a very big project, programmer cannot finish it. Then you need team of programmers. Team of programmers. Right? A team of programmers. All will be working on this project. All will be working on this project. Okay? Then all will be writing some piece of code. Everybody will be writing the piece of code. And suppose he is a team leader, TL. He is a team leader. They all have given the code. Now all that code should be integrated together to form a single project. Who will integrate? Let us say team leader is integrating. Now he will use their code and integrate and make it as a single application. Now, do you think this team leader should know everything in detail how they are working? Does he need to know how they are working internally? He don't have to know. Task is given to them and the task is completed, it is tested, just he has to integrate them. He need not know the logic of the code that they have written. Right? Got it? So just he should focus on joining the things together. Alright? It is just like you are just take a simple example. Just you are taking a meal for lunch. You are preparing lunch at home. Then rice and some vegetables and the salt and various things you take. Do you know from where that rice came? From which field? What is the farmer name who has made that, means that who has grown that rice? You don't know. From where that vegetable came? No. You purchase from a local shop. That's it. What fertilizer was used for that vegetables? Do you know? You don't know anything. Abstraction. Abstraction. So how everything is working, he need not know. That's abstraction. Now I'll elaborate this one. Now these people have written some piece of code, okay? And these people have written some piece of code, and he has written some piece of code. Now they have done it for this project, okay? This project is over. Now there is another software project on this. This is useful. This is useful. Now, shall we directly concentrate on using this on the other project, or knowing how this is working? Shall we look inside that, or simply use it? Already the code was written for the previous project. Now in the new project, it is useful. Shall we look into it or use it? We should simply use it. So same way, this string class was already given by Java. Shall we use it or study it, how it is working, everything in detail? We should not study it, we should use it. But as we are learning Java programming, that's the reason we are learning in detail. But rest of the things we will blindly use them without knowing the internal details. That's what is abstraction. Hide details, show only required features. So just method name is sufficient. The logic of the method is not required. That's abstraction. Alright? So that's what in object orientation we want to achieve abstraction. So now I can tell you something more. See, automobile engineering, car, you drive a car, you use all the functions of a car. Do you know how they are working? Without knowing, you are using it. Abstraction. Television, electronic engineering, television, everybody use. You use all operations of television. Do you know how it is working? No. Abstraction. String class, you are calling methods. Do you know how the methods are working? No. Abstraction. Got it? Now television at home, you are an electronic engineer. Television at home, do you know how the things are working internally? Yes, you may be knowing. You may be knowing it. Right. But what you are using, you are not opening the television box and using, playing with those ICs and circuitry inside the box, but you are focusing on using the function. So you don't want to bother how it is working. So you are watching a match. Do you imagine how the signals are coming in and how it is displaying? This you visualize, or you just watch match? You just watch match. How it is working, you don't bother. Abstraction. That's it. That's the meaning of abstraction. So abstraction gives some peace of mind to the user. So who is user here? We are not talking about the user of a software. We are talking about the user of classes. So this is a ready-made class of Java, and I am using in my program. So I am user of this class. I am user, I am programmer, not the person who is using the software. We are not talking about him. In object orientation, we are not talking about the user of the software. We are talking about the programmers in between only, in between the programmers. So ready-made class is there, that just I should bother about using it. That's what abstraction. So who helps to achieve abstraction in Java? That is classes. Classes are used for achieving abstraction in Java. So I have discussed what does it mean by abstraction. We want to hide the details and show only required feature. So only method name is sufficient. We need not know the method details. Next, see, object orientation is more on designing. Object orientation is more on designing. So first we make a design, then we construct the things. So actually object orientation ideas are coming from other engineering. So if you relate the things with other engineering, definitely object orientation becomes very simple and easy for you. Let us understand this. Let us understand few things. Okay. So before going ahead, abstraction, that was a simple thing I just explained you, but the rest of the things, now this discussion is important. Listen, I have to talk more here in this topic. I have to talk more and you must listen and understand it. Listen. A civil engineer, he has to construct a building. So what he will do, he will make a plan. He will make a plan of a house or building, like there's a door and this is a window, okay, there's a window and there is a room and this is a door to enter in a room and this is a door to enter in a room, like this, okay, and this is a washroom, kitchen, so on, right? So there's a plan of a house. Imagine there's a plan of a house. So first he will make a plan of a house, then he will construct a house. So what is this plan? Plan is nothing but blueprint. We call it as blueprint. Then he will construct a house. Right? He will construct a house. Okay, door is on this side. Chalo. He will construct a house. This house is constructed based on this plan. So first make a blueprint, then make a house. Electronic engineer, suppose he is making a device, say a fingerprint scanner he is making, right? He is making a device, or barcode scanner he is making. So he will make a circuit design first. He will make a circuit design, right? So this is circuit design. Imagine that it's a circuit design, okay? Then he will make that fingerprint scanner, right? Fingerprint scanner he will make. So thumb scanner or fingerprint scanner. So this is the design, and based on the design he constructed this one. Okay. Then same way, when civil engineer is doing paperwork, design, blueprint, and electronic engineer is making blueprint and then making this one. Automobile engineer will make a design of a car and then the car is manufactured. Then what computer science engineer is doing? Computer science engineer should also make a design or a blueprint. Okay. Class employee. Blueprint. This is a blueprint. This is a design, this is a house, which is physically existing house, home, building, object. There's a design on a paper that is in blueprint. Nowadays we are using tools for designing. Okay, after that printout you took. So talk about printout only. Think in terms of paper only. So blueprint. And this is created as per that design, object. This is a design, class is a design, that is a blueprint. Then employee E assign new employee. Object is created. Physical house is created on some plot. Physically a thumb scanner or fingerprint scanner, you can touch it with your hand, you can see it. Object, where it is. When you run the application, when you run the program in the main memory of your computer, this will be created and this will be occupying space, memory space in heap. So really it is created. In the memory it is created. So it's created. Object, object, object. This you can touch and feel. This you can touch and feel. This you cannot touch and feel. It's created. Object is created. Like in a movie, director is capturing a song. Song is created. It's there. You cannot touch and feel. It's there in tape. You cannot touch it, but it's there. Digitally, it is there. You are playing a song. Song is there in your disk, in the file, or in the memory. So same way, object is there. So this is intangible object, not tangible, not physical object, right? So this is for logical things we are doing. So this is an object. Design, blueprint, and an object. Design, blueprint, and an object. Class is a design and a blueprint and object. Yes. Classes are used for making blueprint, and then using those classes we can create the objects, and that's what it is, object-oriented programming. So we are following other engineering, how other engineer works. We software engineers are also working in the same way. See, one thing I will tell you, in the beginning when computer science was being developed, growing, in the beginning, only machine language was there. Later assembly language came. Now who will learn assembly language and who will do programming in assembly language? Everybody cannot do it. Very few people were able to do it. So people used to believe that it is an art. It's an art. By birth he learned, that means he got those skills. Nobody can learn by himself. It is an art. People used to think like this. Then slowly it has become a procedural. So people started learning and developing it. So when some languages came. Now we are at a stage that it should be done in a systematic way. So that's it. So systematic way should be followed. That is object orientation gives systematic way. Alright. So it is matching with other engineering.